Factoring polynomial expressions is critical to solving polynomial equations. Let's look at practicing this skill. Why don't we try to factor 10x to the fifth minus 4x squared? This is a pretty nice case because I see two terms and each of those two terms have some factors in common. So I'm going to try to identify that greatest common factor and factor it out. In this term and this term, their coefficients both share a factor of 2. And the powers of x both share a factor of x squared. This one has 5 factors of x. This one just has 2 factors of x. So we're going to factor out 2 times x squared. I then need to multiply that by the appropriate expression that when I distribute through will recover my original polynomial. So basically I need to provide the missing factors. In this first term, I'm going to need a factor of 5 and 3 factors of x that will be multiplied by the 2 factors to get me 5 total. So that means I'm going to need 5 times x cubed. The product of these two terms indeed gets me 10x to the fifth. I'm then going to provide the missing factor of 2 that gets me the minus 4 here. That's going to be minus 2. I don't need to provide any factors of x squared because there's only 2 factors in this term and I've already factored both of them out. Distributing this through both terms indeed gets me the original polynomial. Let's look at another example. I want us to factor 2x squared plus 2x minus 12. This is a trinomial. It's meaning a polynomial with 3 terms. The first thing I might try to do is look for any common factor to all 3 terms, and all I see is a factor of 2. It may be worthwhile factoring that out anyway. So let's go ahead and do that and see if it makes our life simpler. I have x squared plus x minus 6, and I'm going to see if I can factor this trinomial further. I'm hoping that it factors into a product of 2 linear factors. The first term must multiply together to get me x squared, and the only way that that's going to happen is if I start each factor with a term involving x itself. I then look to the last term, and it's supposed to be minus 6. That's going to come from multiplying the 2 last terms of my missing factors together. So I start thinking about the factors of 6. There's 1 times 6, and there's 2 times 3. 1 times 6 doesn't seem very hopeful because the product of the outer and inner terms with those factors have to add up to 1. It seems unlikely that 1 and 6 via addition or subtraction is going to give me that middle term of 1 times x. So instead I'm going to try the other factorization of 6, 2 and 3. Initially, I just like to put minus signs there. However, because the product has to be minus 6, one of these signs has to change. I think about that middle term, and because I want it to be positive 1 times x, I'm going to put the positive with the 3, so that I end up with a little bit more positive when I go 3 times x minus 2 times x. That will add up to the 1 times x. You just want to double check that this works. I'm going to mentally FOIL x squared. The outer terms gives me a 3x minus a 2x from the inner terms, and then minus 6x from that last term, and it indeed gives me the expression above. Let's look at another example of factoring a trinomial. Let's take 2x squared plus 7x minus 15. Unfortunately, now there's no common factor that I can factor out, and I'm really just stuck working with something whose leading coefficient is not 1. But we're going to still try to go ahead and factor this, and the only way to make it work, because factors of 2 are just 1 and 2, is to use 2x and x. I then have to look at that last term of 15, and I think about the different factors of 15. I could have 1 and 15, but addition and subtraction of that doesn't seem to lend itself to giving us 7. It's not quite that simple, because I also have this 2 here that will affect whatever that I put there. But I just feel uncomfortable about 1 and 15. So I'm going to try 3 and 5 first. I'm going to write them down in one order. Let's try 5 here and 3 here. It really does matter again because of the 2. Initially, I'm going to put minus signs in both places. When I multiply them together, right now I'll get positive 15, and I want it to be negative 15. I start thinking about changing the signs here. Maybe I put a plus here, maybe I put a plus here. But regardless, their product has to give me, their sum of those terms when I add them together has to give me positive 7. So if it's 5 here, that's 5, and I'll get 2 times 3 is 6, and it's unlikely that addition or subtraction of 5 and 6 is going to give me that 7. It just doesn't seem likely that this is going to work. After a while of trial and error, I just give up and I try a different choice. And the only other choice I can think of is to reverse the order of the 3 and 5. So I'll put the 3 here now and the 5 here. Initially, I'll put minus signs. I start thinking about changing the sign of one of them. And if I put a plus here, that's going to be helpful because I'll get 2 times 5, that gets me 10x. And I'm going to take away 3x, that gets me 7 total. The difference in sign will ensure that I get minus 15 here. Just mentally check. 2x squared, 10x, minus 3x gives me the 7x totally, and minus 15. And we're done. You may have learned various techniques for factoring trinomials, but really I just encourage you to work via trial and error, and if that doesn't work, just move on. There are some common situations, such as the difference of squares, that you should be familiar with that will help you factor. In this example, I have 4x squared minus 9. Each one of these terms is a square and they're being subtracted together. You're always going to be able to factor this kind of situation nicely. And the first thing you want to do is identify what's being squared. In the first term, it's 2x that's being squared. Squaring that will give me 4x squared as it appears over here. And then I'm subtracting 3 squared. This can be factored as 2x minus 3. In other words, the thing that's being squared here minus the thing that's being squared here. And then you multiply it by a similar product but with a different sign. In this case, I have 2x plus 3. The reason for the different signs is that it will give us minus 6x from the inner terms plus 6x from the outer terms, and they will cancel out, giving us no x term. So just check here, I get 4x squared, all the middle terms cancel out, and then I get minus 3 times 3, and that gets me minus 9 as it appears here. So we've successfully factored this difference of squares.